And welcome back. We are now going to go ahead and dive into a little bit more looking at our derived classes, specifically the different pieces of them and how they work in relation to our base classes. And to start us off, we're going to first look at how we override a method. Now, this is one of those kind of key concepts that Java has, which is overriding. Now, overriding is simply just when we have an inherited method that can be changed within the definition of our derived class, so it is a little bit different than what happens within the base class. All right, and because that definition allows us to do that, we can do things like, for example, look at the toString method and the equals method, because these are ones that are very commonly overridden and therefore redefined within the definition of any derived class, because a lot of times you have new properties that you need to check for within those derived classes that didn't exist within the base class. Now, to override a method, we simply just give a new definition of the method in the derived class. We don't have to do anything super fancy or complicated. We don't need any new keywords like extends in order to note that it is a overridden method. Now, there is something to know about changing the return type of an overridden method. As we have talked about, we can override or change the definition of a method from the base class. Now, generally speaking, though, if we want to override a method, we can't change that return type returned by the method. So, for example, if it was a void method, we're not going to change it all of a sudden to returning an integer. Now, there is a small exception to this rule, which is if the return type is a class type. So, for example, if I return a class employee or a class hourly employee, then we could change the return type to that of any descendant class of the return type. So, for example, if originally I returned, let's say, an employee class, then my derived class, let's say it's an hourly employee I'm working with, I could return an hourly employee. All right, and it has a special name, which is known as a covariant return, because we are effectively operating under two. So it's a covariant. You're working with two different things here. Now, when we look at those covariant return types, it's worth noting that when you change the return type from an overridden method, such as employee to hourly employee, you're not really changing the return type so much as placing additional restrictions upon it. All right. As we've already kind of talked about, when we have derived classes, they have additional properties. So like hourly employee, remember that is technically an employee object. It just has additional properties. And it's easy to remember that because, well, if an hourly employee exists, remember it has things that an employee doesn't exist with. And because of that, it's more restricted because there's, not every hourly employee is an employee. You might have, for example, salaried employees, which aren't going to have the exact same properties. Now, any code that was written for a method of the base class and that is assumed the value is returned by that method employee will be legal for an overridden version of the method that returns an hourly employee. All right, and as we know, this is going to work because, well, an hourly employee is simply just going to be another employee. Now, what about changing the access permission of an overridden method? All right, this is when we start looking at things like public or private modifiers. Well, we can change the access permission of an overridden method from private in the base class to public in the derived class, or really kind of any other way that makes the access permissions more permissive. In other words, you can't make them more restrictive. You can go like private to public, but you can't go public to private. So that is one important distinction here if you want to change that access level. So for example, if we have the following method in the base class, private void do something, then in the derived class, we could change it to public void do something. And that would still technically be considered overriding the method. It just, all you've done is you change the security restriction. Now, when we start talking about restrictions for those overridden methods, you'll notice that we didn't necessarily change the permissions to make them more restricted in the derived class. All right, we can change, of course, private to public. What we cannot change from public to private, as I already mentioned. All right, if that's the case, well, we want code written effectively for the base class methods to work for that derived class methods. And we got to make sure things are still going to work in harmony. And if you try to reverse that, you're going to run into issues with accessibility. If you can use a public method any place you can use a private method, but it's not true that you can use a private method any place you can use a public method. All right, as we've already talked about, in the base class. Remember, you can have those private methods, but in the derived class, you can make them public because, again, another way to think about this is the same way as when we start looking at some other pieces. The derived classes are much more specific. They have a lot more, not necessarily restrictions is the right word, but a lot more properties attached to them. And because of that, we can make things a lot more fine-tuned for those specialized objects. Now, there's one small pitfall that we need to make sure we point out, which is the difference between overriding a method versus overloading a method. And we've talked about overloading before. But I don't want you to get these two things confused, all right? Overriding is not the same as overloading. And one of the biggest things is, remember, overriding usually refers to multiple classes. Overloading is referring mostly to a single class. So when we override a method definition, the new method definition given in the derived class has the exact same number and types of parameters. All right, remember when we overload, we were changing, if you remember from when we did this program 1, we would change our method definitions of different things. Like, for example, let's say we had a string, an int, and a double parameter, and we wanted to overload that. So now we have a string, an int, and 2 double parameters. Well, that's overloading, all right? Overriding, you're keeping those parameters the same. With the overload, remember, they can vary from type to type, all right? And with that, if you look at how these kind of function, all right, if the method in the derived class were to have a different number of parameters or a parameter of a different type from the base class, well, then technically our derived class would have both methods, all right? It's not simply just overloading just one. So it is a little bit of a trick here to kind of keep this in mind because, again, they're not the same thing. Overriding is effectively changing the definition, whereas overloading is creating multiple variants of that definition. And just to kind of give you a little bit more on the overload versus override train here, let's say we look at our hourly employee class, and let's just say we create 2 methods called set name. So public void set name, string new name, and public void set name, string first name, string last name. On the other hand, if let's say our employee class and the hourly employee class both define a method with this heading, public string toString, all right, and this does actually exist within our class. All right, we actually have toString methods in both our employee and hourly employee class. Well, if we look at these 2 examples here, the hourly employee has only one method named toString, but the definition of the method toString in the class hourly employee is different than the method of toString in the class employee. And because it's different and we didn't change the parameters, this would be an example of a method that has been overridden, or another way to think about it is redefined. Whereas we look at our 2 set names examples here, this is an example of an overload because, and you notice the method has stayed the same within a single class here, but we have different parameters between them. So again, this is kind of one of those important concepts to kind of remember is this difference. All right, and last thing I want to kind of touch base on here real quick is the final modifier. This is one other little modifier that can kind of sneak in on us, and it does play a little bit of a role. If we add a modifier called final to the definition of a method, it will tell Java that that method cannot be redefined in a derived class. So if I were to take, for example, that set name method and put final on it, I can't go and redefine what set name is in any derived class. It means this is the final version. And because it's added final, it also means that the class may not be used as base class to derive other classes. So be careful if you use it. All right, if you say this is the final class, that means that this is the final version of this. I'm not expecting any more descendants of this class. So if you put in the class modifier, this is in a method. If you put in the class modifier, it means you can't have any more derived classes. A final method just pretty much, again, means you can't redefine it, whereas in a class, it means that you can't make any derived classes. All right, and so I just wanted to give a real quick example of showing that override property here. So here is my employee class that we looked at previously. And we notice we have a public string toString, and we also, of course, have public equals. All right, and if we look at how these function, if my toString, I have the name instance variable, plus one concatenated space, plus higher date.toString. If I look at this one with the equals, I have name that equals other employee name, and higher date that equals other employee higher date. Pretty self-explanatory of how those work. Now, if we look at the derived class, you'll see that there is some change in how those work. So for example, I don't have name here anymore, all right, because name is a private variable that exists here with an employee. So I have to use the getName method. And so that will effectively still get the same value, but because it's private, I can't access name. So I have to use getName instead. Then of course I use the getHireDate method here because again, we don't have access to that variable. And you'll notice with this one, I'm doing a .toString, all right, because very similar to that we had on here, we have a .toString because we want to take that date object and convert it into a string. And then we, of course, have some other things on here that are unique to this hourly employee class. And you'll see we have wage rate, we have hours. These, again, are things that are unique to this class. This is what we're talking about when we start redefining a method when it is overridden. Similar things will happen down here with the equals method. You can see we have getName, getHireDate, and of course, you'll see we also have this part right down here, which is, again, the pieces that are unique to this hourly employee class. So the biggest things that point out here is, one, you can't put those variables directly in here because they are going to probably be private, so you need to use your accessor methods to actually pull those same values. And you will start using variables that are unique to that derived class.